Ant-Man is unique in the MCU. It's the only Marvel movie where they try to explain the hard science. And that's exactly where they went wrong. Well, the movie explains that Pym particles reduce the space between atoms. So that means if Scott Lang shrinks down to the size of an ant, his mass stays the same. On paper, this sounds so smart, but the issue comes when they try to have him fly on an ant. So he's light enough to fly on an ant, but they want him heavy enough to be able to punch bad guys. They treat mass as this volume knob, where they can increase and decrease it depending on circumstance. And the greatest offender is Hank Pym's luggage. In Ant-Man and the Wasp, Hank Pym is carrying a rally case full of about 30 cars. Now, a real Porsche 911 would weigh around 3,300 pounds. The movie says that shrinking doesn't change mass. So that means this car should weigh 1.5 tons. So Hank Pym is casually walking around with 30 tons of German engineering in his right hand. I think that's a real superhero we need to be talking about in this movie. Hank Pym is the strongest person on this planet, I swear. And don't even get me started on that portable lab. It's made of concrete, glass, and steel, and definitely weighs thousands of tons. And he's just casually walking with it on the sidewalk. That suitcase wouldn't just roll on the sidewalk. Weighing that much, the suitcase wheels would puncture through the concrete like it was tissue paper. So we know the movie is lying to us, but how far those lies go just to keep Scott Lang alive is what this video is about. So let's dig into why Ant-Man is impossible. What if Scott Lang actually keeps his mass like the science claims? Well, that brings us to density, and more specifically, pressure. Pressure is equal to force divided by area. Normally, my weight of 200 pounds is spread over both of my feet. But if I were to put all that mass into the tip of a pinhead, I wouldn't be a person anymore. That would be an armor-piercing round. So if Ant-Man balances on your shoulder, he wouldn't balance there. He would puncture straight through your skin, your muscle, and your bones. But density is just the beginning. The real physics nightmare occurs when Scott Lang goes subatomic. To explain why, we need to talk about escape velocity. Escape velocity is the velocity needed to escape Earth's gravity. For Earth, that's about 25,000 miles per hour. So if I throw these keys any harder than that, they're never coming back. If I crush the Earth down to the size of a marble, the gravity would become so immense that the escape velocity would approach the speed of light. So as Scott Lang shrinks into the quantum realm, his gravity increases, and his radius reduces to the point of the Schwarzschild radius, the radius at which light can't escape your gravitational pull. And since nothing travels faster than the speed of light, nothing can escape him or his gravitational pull. So he's not just an Ant-Man anymore. He becomes a black hole in the middle of a giant city. Instead of protecting his daughter, he's enveloping her into a gravitational pull and turning her into spaghetti. I think the Dad of the Year award goes straight to Scott Lang. Or should I say Grandma of the Year. Okay, so option A, he keeps his mass as he shrinks and becomes a black hole that envelops the entire city, or a human bullet. Option B's gotta be better, right? Wrong. Now he suffocates. So the movie says they shrink the size between atoms, but that doesn't mean they change the size of every other atom in the universe as well. So oxygen is the same size as it was before Scott shrank. Here's the issue. So if we take this Nerf dog ball as an oxygen atom, where two of them would make O2, the oxygen that we breathe, then as Scott's nostrils and his blood vessels shrink, there comes a point where they simply won't fit. So he doesn't have any oxygen in his blood. Or he shrinks so fast that the blood vessels are basically expanding in his nerves, and his nerves all explode, causing very painful internal bleeding. But his main issue is once he gets down to that size, he can't breathe anymore. He's going to suffocate and die in 30 seconds to a minute. So let's review. If Scott keeps his mass when he shrinks, then he becomes a human bullet. Then if he goes subatomic, he becomes a black hole that envelops the entire city. And let's say he does shrink his mass as he shrinks with it, then he suffocates because of the oxygen being a little bit too large for his nostrils now. So the Ant-Man is physically impossible, and Scott Lang would die very quickly if this were true. Ant-Man is a fun movie, but strictly speaking, it's the worst physics offender in the entire MCU. Completely scientifically inaccurate. Even the talking raccoon makes more sense. But that's all I have for you today.